In this problem, we are calculating initial intensity level, that means intensity in terms of decibel, and what will happen to the intensity if distance will change, and how it will increase it or decrease its intensity level with change of distance. So a sound with initial intensity was 1 microwatt per meter square, and we have to calculate what is its intensity level at that point due to this sound, and what is its intensity, new intensity, if distance will decrease to 1/3, and what is its intensity in new point. So first of all, write what is given. So in this problem, the initial intensity is given, which is I, that is 1.00 microwatt per meter square. This is intensity, which is measuring power per meters per area. So I can convert this into SI system of unit. Microwatt means 10 to the power negative 6 watt. So that is equal to, this one is basically 1 microwatt per meter square is 1 times 10 to the power negative 6 watt per meter square. Now what you have to calculate? In A, we have to calculate what is an intensity level, that is beta, Greek letter V, in decibel. And what is a new intensity? All right, I new, when the distance is decreased by 1/3. And third one, we have to calculate what is the intensity level at new point, what is beta new. So start from A. So we do have the formula from formula set. Beta is equal to 10 log I divided by I naught. In this case, the I naught, I0 is minimum intensity which we can detect. That is found, and standard value is 10 to the power negative 12 watt per meter square. So this is standard value. It's given, it's known, which is a minimum intensity which can be detected. So all the values are given, known. So switch these values to calculate. 10 times log I is given 1 times 10 to the power negative 6 divided by 10 to the power negative 12. Yes. So 10 to the power negative 6 divided by 10 to the power negative 12. If you solve this, you will get 10 to the power 6. Yes. So one has a special property for this log. Log x to the power y, that is equal to y times log x. So same thing over there, log 10 to the power 6, which you can write 10 is as it. So log 10 to the power 6 can be written as 6 times log 10. So this 10 log is 10 less log. So this value of log 10 is equal to 1. So that is 10 times 6 times 1. So if you multiply all together, we'll get 60. That is intensity level, which is measuring decibel and written by dB. So this is first part. Second part, we have to calculate intensity with change of distance. So we know that from the formula, I is proportional to, inversely proportional to square of distance. So if you decrease the distance, intensity increase. If you increase the distance, intensity decrease, which is clear. If you go far away from the source, you will get less and less louder sound. So intensity will decrease. So it means if I do have I new, then that should be proportional to new distance. Yes. And if I do have I old, then it should be proportional to 1 divided by R whole square. So if you combine this together, what we get in ratio, I new divided by I old is equal to, so on the top is 1 divided by R new squared divided by, on the bottom is 1 divided by R old. So there is proportionality sign which will cancel for both of them, and it's squared. So that is equal to, I can write the 1 divided by R old, which go off, so R old, yes, divided by R new, which is remains on denominator, and there is square term over here. But it is given R new is 1 by third of R old. So distance will decrease. Yes, decrease is decrease. So R new, instead of R new, I can write R old divided by 3, and it's square. So this all R old will cancel. Then what do you get? 1 divided by 1 divided by 3 square. So which will go? 3 goes up, that is 3 squared. That is equal to 9. So it means if I solve it, R new is equal to 9 times I whole. So it means if you're coming closer, then intensity level increase, loudness increase. So if you decrease the distance by 3 times, the loudness increase by 9 times. Similarly, if you decrease the distance by 4 times, loudness increase by 16 times. And on the other hand, if you are increasing your distance 4 times increase, then the loudness decrease. How much? 16 times less. If you increase the distance by 3 times, you are increasing distance, so loudness decrease. So loudness will decrease by square of that. That is 9 times less. So we are now move to problem number C. At that point in new intensity level, we have to calculate what is the value of intensity level, which is measured in decibel. I can also calculate I intensity in terms of numerical value. 9 is given. It is added. I always we do have already have 1 times 10 to the power negative 6 watt per meter square. That is 9 times 10 to the power negative 6 watt per meter square. Yes. Now we have to calculate intensity level. We now have beta nu. So from equation, I can rearrange this equation 10 times log of I nu, because I am calculating new beta level, so divided by I naught. So I naught is constant, switch all of this value, 10 times log I nu is 9 times 10 to the power negative 6 divided by this is 10 to the power negative 12. I naught is given 10 to the power negative 12, which is standard value. So as like earlier, we can solve 10 times log of 9 times 10 to the power negative 6 divided by 10 to the power negative 12. That is, will give 10 to the power 6. Yes. 9 times 10 to the power 6. So this one is, we can solve it by using calculator. So 10 times log 9 times 10 to the power negative 6 will give 6.95. Yes. So if you solve this together, we'll get 69.5 decibel. So look at here, if you decrease the distance by 3 times, the intensity increased by 9 times. So initially 1 micrometer per meter square, microwatt per meter square. Now it has intensity level 60 decibel, as I calculated in problem number A. If you decrease the distance by 1/3, then the source intensity would be increased by 9 times, which is 9 microwatt per meter square, but intensity level will not increase by 9 times. Okay, intensity level increase from 60 decibel to 69.5 decibel. It is increased by only 9.5 decibel more.